Welcome back to some more geometry. Today we're talking about angle measures. Now, in case you guys don't know, this right here, called a protractor. It's used to measure angles. For example, let's see if I can grab this one. Yeah, you put this little end right there, right where the angle starts, the vertex angle, and then you just turn this as needed. This one won't let me turn the picture, but if it did, it will let me do that. All right. That being said, let's kind of talk about angles to begin with. So, angles are made up of two things, actually. An angle is made up of what we call a ray. Now, a ray is called a ray because, well, like a segment, it's part of something else. So, when we talked about lines, lines don't have endpoints. They go on forever and ever. The segments have two endpoints. Well, a ray is the love child of a segment and a line. It has one endpoint one end, but goes forever in another direction, opposite of that endpoint. So a ray has one endpoint and one part that goes infinitely to the opposite side. Opposite rays are two rays that have a common endpoint and extend opposite. So technically, you could say, hey, there is this ray, these two opposite rays, the one that goes that way forever, and then this one. Oops, that's a horrible. You get better than strong, but that's cool too long. This one, or it can have it right here at B. Say one that goes this way, and then the opposite ray be over here, with this being the common endpoint. Or you can do this one where it's at C, where this is the common endpoint. One going this way, and one going that way. Okay, that's so. For example, BA and BC are opposite ray. Now, even though these lines up here, kind of like the lines and segments, these will always face towards the right. Doesn't matter where it starts and where it ends. It always faces the right. Okay? Now, what goes first is where it starts. For example, they're saying, hey, BA and BC, BA and BC are opposite rays because they both start at B. We go B towards A, that's BA, and B towards C. That's the other one. They are opposite rays, same common endpoint, heading in opposite directions. So that's opposite rays. Now, an angle, like we said earlier, an angle is formed by when two rays have the same common endpoint. We call that the vertex. So the rays of an angle are called now sides. So this whole link right here and this whole link right here, that's a side. And this is a side. The common endpoint, that's our vertex. And what's inside, the space in between, determines what kind of angle it is. What kind of angle it is. So for example, we have 4 types. So we have an acute angle. Anything from 0, or really 1, greater than 0, to 90 degrees. So it can be as small as this, but as large as this, as long as that's less than 90 degrees. And go all the way to 89.9999. As long as it's less than 90, we're good. A right angle is exactly 90 degrees, so it's a horrible 90 degrees. Let me get... Is that what I want? Nope. How about... There we go. It's exactly 90 degrees to go straight up and down, straight side to side. This is exactly 90 degrees. You'll see it'll still have a little ray mark. And then the way they will measure it sometimes, the way they'll write it in your book is to put a little red square right here in the corner. All right, that's 90 degrees right there. An obtuse angle is anything greater than 90, but less than 180. So it's greater than 90, so just barely over the 90 degree mark, but not quite straight line, not quite flat right there. Okay, and then this is what's being measured. These are the degrees we're talking about. From here to here, here to here, that right there. All these distances in between. A straight line, a straight angle, is exactly that. It is an angle that is straight. This is a straight angle. Little endpoints at the end. It's exactly 180 degrees. Okay. It's being measured from one ray with the common endpoint being right here, probably in the middle. Measure between. That is a straight angle. So we have an acute angle greater than 0, less than 90. A right angle, exactly 90. Obtuse angle, greater than 90, but less than 180. And a straight angle, which is exactly 180. So let's look at this right here as an example. So you should name them. So, for example, angle RXS. So the way you label these is by the letters that make up that angle. So starting at R to X to S. So R, X, S. So we measure this on the inside, this right here. What kind of angle is this? Anybody? Anybody? Yeah, it is an acute angle. An acute angle. What about angle TXB? So we got angle T straight down to X, then to V. What would that be? Yeah, it is a right angle. Now, why do you think it's a right angle? For sure, because it doesn't have the block over here. It does have it over here, and because RXV is very obviously a straight angle, because this half is 90, then the rest of it also has to be 90. So you can make that assumption right there. Let's look at the last one right here. Angle SXV. S all the way to X, then to V. So you're measuring from here, this ray, all the way to this one. What kind of angle is that? Yeah, pretty obvious. Obtuse angle. It is an obtuse. It's greater than 90, but not quite a straight angle. Okay, so let's talk about different types of classifications for angles. So angles, anything's congruent angle, congruent, are angles that have the exact same measurement. Whether they're facing the same way, up, down, left, right, doesn't matter. If the measurement inside is the same, they are congruent. Again, we talked about this word before. Things that are congruent means they're exactly the same. A sign for congruent is that. Now, the difference between congruent and equal is strictly talking about numerical values. Congruent means they look the same, they act the same, they have the same, they don't look, but they're not necessarily in the same pattern. So, for example, if I have, let me take this little triangle, and I will then duplicate it, move it, and turn it. So you saw me. I made this triangle, took this triangle, copied it exactly, and then just flip it. They are congruent. They may not look the same as because they're not pointing the same, but they are congruent. The measurements, the length to the sides are all the same. Adjacent angles are two angles that are right next to each other. So they share a vertex on one side. A bisector of an angle is the ray itself that cuts an angle in half. So let's kind of look at this right here. So for example, let's take this angle right here, RXS, this angle right here. What angle is adjacent to it? Doesn't have to be equal to it, it just needs to be adjacent to it. What angle is adjacent to it? This one right next to it. So we're talking about this angle right here. This is the angle right next to it. SXT. So as to say, name two adjacent angle RXS, and angle, the one right next to it. You always start with the side. You can just go right here, go TXS or SXT. They're the same thing. Angle SXT. That's what this little sign means. You're referring to it as angle RXS. But instead of writing angle out every single time, we can just write the symbol angle. All right, so the next problem now asking name two angles that are congruent, meaning exactly the same. All right, so what we're doing right here is we're going to look at this picture right here. See what we got? That right there. Now, we're talking about it right now. When they share the same little symbol right there, same little curve, that means they're congruent. They're saying they're the same angle, same measure, same measure. These two are the same to each other. And as it said up here, congruent angles have equal measure or the same measure in this case. So we could say, as we name them, since they have the same little mark, they are the same. So we say angle, and I'll start with the first one. I'm going to do VXU. So if you pause this video, what will be the other one? Two possible answers. We can go with angle QXU or angle UXQ. What is the most important part is that the vertex is in the middle. One can start, the other one doesn't matter. It's still the same angle, QXU, UXQ. You can't say QUX, UQX. That's improper and really just weird, irresponsible. Come on now. Come on now. Now, what angle is bisected? So what angle, for sure, looking at this, was cut into two equal parts? Remember, bisects means to cut into two equal parts. Bisect means to cut. So, since we just talked about two congruent angles, these two smaller angles are the same. That means the original big angle that makes both of them up, QXV, angle QXV, that angle got bisected by a ray. What's in the middle? What ray is in the middle? This one right here. Ray XU. Ray. Okay, so bisect. What angle is bisected? What was the big angle that originally got cut in half? What ray did the bisecting? XU. All right, last part right here. So, excuse me. Ray XU bisects QXV. So it's telling you that this right here cut this big one in half. That's why these are equal to each other. They have the same low mark. So let's go if VXU, so this right here, is equal to 4x plus 15, and UXQ is equal to 8x minus 5, what is the value of UXQ? UXQ. So they're asking, what is this ultimately equal? So this little m right here stands for measurement. Measurement. So the way you read this is, if the measurement of angle VXU equals this. So when we're talking about the measurement, we're looking for an actual number, an actual value. So let's do that. Like we said before, these two equal each other. So if the angles themselves equal each other, then the expressions that they say also equal each other. So we can say 4x plus 15. Let me fix that. Okay, a little weird. There go 15 equals 8x minus 5. All right, so let's do a little bit of algebra here. So we'll get all the x's together. So we'll move the. Right. We're going to move the 4x over here. So we subtract 4x from both sides, minus 4x minus 4x. And we're going to then, since we move the 4x over here, we're going to move this 5 over here. So we add 5 to both sides, plus 5, plus 5. When we do that, we're left with 20 equals 4x. And then to solve for x, you divide by 4. You get 5 equals x. Now, is that the answer? No, that's a answer. The question is, what is the measurement of this angle, UXQ? Well, let's put a 5 right there, slip it to the end there. We end up getting 8 times 5 minus 5. So 8 times 5, 40, minus 5 gives us 35 degrees. And that's today's lesson on angle measurement. Y'all have a great day. Bye, baby.